Hello everyone, welcome once again to another data analysis tutorial by Slidescope. In this part, we are learning how to create a penguins classification data analysis dashboard and try to see effect of different type of variables like eye length, bill depth, flipper length, body mass, gender, year, etc on the outcome, that is the species of penguin. In the data set, we have three different types of penguin: Chinstrap, Adelie, and Gentoo. And in this tutorial, you are going to learn how to create a dashboard that has this kind of filter where we can see data on the basis of different penguins type, data on the basis of different numerical variable comparisons, and we will also see how we can create this type of matrix where we can see two categorical variables and a value that is from a numerical variable. All of this will be discussed in this part. So let's get started and learn all of this. So here is the data set of penguins. It is a very famous data set that is used for supervised machine learning. In this data set, you can see we have ID, we have a species, and island. A species represents three types of penguin: Chinstrap, Adelie, and Gentoo. These are the three different species of penguin, and they are found in different islands. So Torgerson, Bisco, and Dream are the three islands. Some penguins may be found in two different islands also. Now, their numerical data like their bill length and their bill depth are given. So you can see this is just a representation of these penguins, may not represent them most accurately, but for these three types of penguins, for these three species of penguin, their bill length and flipper length are different, right? Or their bill length and flipper length can be different, their overall length can be different, overall height. So the data set contains bill length information, bill depth information, flipper length in millimeter, body mass of these penguins in grams, their gender, and it also has information of year in which they were found. So now in this particular, this is the simple information of what do we have in the data, and we have the clean data. There were two rows with missing values. We have simply removed them. So in total, we have 343 rows here in the data set. Now let's get started with visualization. Now we have our Power BI desktop. Using Power BI desktop, we will simply connect the dataset. I have the dataset in Excel file, so I will use Excel workbook connector here. I will provide the link to download this dataset. If you get the dataset as CSV, then you have to use the CSV connector. Now in the dataset, we will simply connect it and make sure all the columns are properly aligned with their values. Now here we will simply load the dataset and it will bring the data in our model. Now the first thing that we are going to do is add a text box as a heading and just bring our image. What we can do also, for example, if you don't want like this, so you can go to the insert tab. From insert tab you can insert some shapes. For example, I want to insert this shape, right? And in the shape, whatever information you want to provide, you can write. So like we can click here and then we can bring the text box over this shape, right? So we will simply bring a text box over this shape, and in the text box we will write penguins classification data analysis. This particular data set is used in many machine learning predictions, and earlier there was a data set which was iris data set, and this is just like a replacement of iris dataset. It is also very old dataset and very famous. Now here we will simply use a lighter color for this, and we will go to effect and just enable its background. Like we'll use some different type of background here. So we are going to use a black background because of our image style, and in the shape itself we are going to use a dark color. Okay, so this way you can enable some kind of shade effect here, and you can align your this particular text field to wherever you want. Okay, so this way you have the penguins classification data analysis, just the header here. And now after header we will insert image. So the image that I was using before, this penguins image, we will use that image. So get images here, just click on image and select from your computer. I created this image using AI. If you want, I will provide this image also. Now here we have the Chinstrap, Adelie and Gentoo image, and we have almost prepared our dashboard for bringing visuals here. If you want, you can do one more simple thing here, like this image you can resize, and in your image when you will select this in your formatting, go to general tab, effects, and you can enable a shadow. So this way your image will stand out, and it's totally optional. Now in the data set, first let's understand different things. So in the data set there are three species given. This species column is actually our target variable. This is like the output variable, and we want to see what is the effect of these different input variables on this output variable. Like what is the probability of finding a species. And when we do machine learning, in machine learning we provide these values like gender, body mass, flipper length, bill length, bill depth, and island. We will provide these values to a model, and model will predict what type of penguin you are talking about. So for doing exploratory data analysis, first you have different combinations here. So if you have a numerical value here and another numerical value, and you want to see how these two numerical values are related to each other, like if we increase bill length, will bill depth increase, will flipper length increase. So we will create some scatter plot here. So just bring a simple scatter chart, and in the scatter chart, in x-axis and in y-axis we will bring bill depth and bill length. Okay, now it will obviously create a simple dot here because by default Power BI summarizes the data. So we'll say don't summarize, don't summarize. Okay, and now you can see, if you will watch closely, you can see, I can at least see there are two different type of groups on the basis of bill depth, right? If we are increasing bill depth, so there and bill length on the basis of these dots. These dots are our information of every penguin. For example, this is information of some penguin having a bill length of 58 and bill depth of 17.8. So this is the information. First we will go to general tab and call it bill depth versus bill length. Okay, and we will just make it bold, align it to use the same color, or let's use a slightly lighter color or this color, and we will align it to center. Okay, now we have bill depth versus bill length. We can again go to format visual, go to effect, and enable a simple shadow for it. In bill depth versus bill length, to see their effect on these three different type of penguins, we also have legend field here. Okay, in a scatter plot, in legend field you can always bring a column or a field that is categorical, and the categorical field that we are targeting here is species. So now we will be able to understand that Gentoo, In Gentoo penguins orange color, these penguins have a smaller bill depth but longer bill length. Okay, shorter bill depth, longer bill length. In case of Adelie penguins, their bill depth is, you can see, higher, higher or same length as of chin strap penguins, but their bill length is shorter. And in case of chin strap, bill length and bill depth are both in some average range. Okay, so this is something that you can see, and that because we have not summarized the data, so this is the actual graph. Okay, whatever color you want to choose here, you can choose. For example, when you have selected the graph, you can go to format visual. You can see markers. Marker shape by default is this dot shape. We can also select diamond shape. Okay, the style is fill only or border only. If you want to see about, you know, whatever way you want to see, and these are colors. So Adelie is being represented as this blue color. So let's say we want to represent with this black color. Okay, just giving some, just giving a color that kind of represents one of our theme color, or I will use this one, a little darker color. So this is our bill depth versus bill length of these three penguins. We can make a copy of this, and after making a copy, here we can replace the variables. Okay, so let's align it to, let's increase its length a little bit because we will be putting three columns here, and we can increase the length of this also. Okay, now the second graph that we are going to make is between bill depth and flipper length, or bill length versus flipper length. So let's take bill length to x-axis and flipper length to y-axis. We are basically analyzing this data just to see that, don't surprise. So we are just analyzing this data just to see if x and y, by visualizing these two variables, do they have some kind of effect on a species. And if you will see, yes, there is some range, and in the graph we can, see them in three different groups. Same when you are doing bill length versus flipper length. Okay, so let's just change the title here so that it's not confusing. So this is bill length versus flipper length. Okay, so bill length versus flipper length. In this case also, we can see that Adelie penguins have, obviously we saw that they have shorter bill length, but they also have shorter flipper length. Okay, shorter bill length, shorter flipper length. Then Chinstrap and Gentoo have larger flipper length, shorter flipper length. Obviously, these images, I am again saying, may not represent it correctly, generated with AI, but we can see from the data also, and as you know, imagine how these penguins would look like. So a smaller bill length, a smaller bill depth, and a smaller flipper length. So these Adelie penguins have. Now we will again make a simple copy of this. Okay, and we will simply put the data here, and here I will just reduce its size so that if you want to put, you can put more variables here, or maybe later. We'll see. Now here the important variable to analyze will be bill length versus the body mass, or body mass versus the flipper length. Technically, if you have four variables, you have to see them, see the relation of every one of them with every one other. So in something like Python, there is a graph Seaborn. There is a graph called pair plot. Okay, so you can also use the pair plot to create that. But here you can simply use keep using Power BI, and here we will show that, and we'll create another video where we will give you another link of video where we have shown the same kind of exploratory analysis with Python. Here we are going to put flipper length versus body mass. So we are saying if flipper length is increasing, is body mass also increasing? Okay, and we will just use don't summarize. In this case, you can see the orange ones very clearly, the Gen2 very clearly, and make sure that in all three cases we are using orange color for Gen2. We are using this dark blue color for chin strap and this black light color for Adele. That's why we are copying this, right? Otherwise, we may get confused. And here, this is between flipper length and body mass. We can see, first of all, we can see a linear relationship between flipper length and body mass for all of them. Like, so you can go to trend line and enable a trend line. You will be seeing a positive trend line, which shows us that there is a positive, you know, slope here. That means when flipper length is increasing, body mass is also increasing, because length of flipper lens adds weight to a penguin, right? So that's logical also. And here we will simply go to visual and title. So just correct the title. So this is flipper length versus body mass. What you can do, you can create all of them. Okay, you can create a simple pair plot. When I am talking about pair plot, here is the pair plot. Here you can see we have 16 different images for 4 numerical variables, 4 into 4, a grid of 16 images. So you can also create them. Here in Power BI, we are just showing you use of 2 or 3 of them. Okay. Now, whenever we are visualizing this type of data, we also have the numerical variables. For example, when you are creating 4 by 4, so this particular graph is representing bill length versus bill length. So there is no point of visualizing the same variable with the same variable. So in that case, pair plot shows you the distribution of that variable, how the values in that variable are distributed. How to create that distribution plot here? So we can use a stack column chart or a clustered column chart here. Sorry for noise. So a stack column chart or a clustered column chart. So here we will use a stack column. I will tell you later why I have selected that. And I will simply click on it, go to Home tab, choose Format Painter and apply the same style first of all. And I am showing you one of them. You can create different copies and you can replicate the same thing for different variables also. For example, let's see how bill length is distributed. Okay, so in case of bill length, first I will show you without creating any type of calculated column. So first drag bill length on the x-axis. Okay, and on y-axis we will just bring count of penguins. Okay, so every penguin has a unique ID. So we will just bring that ID and count of that ID on x-axis. So in a way you will start seeing a distribution chart here. In this distribution chart, the groups of values in bill length, like it is starting from 30 point ending at 60 point, 60 mm, and here you can see the groups are all over between these ranges, right? And you can see we have too many values here. So in order to narrow them down, for example, here you can see 1 2 3 4 5 6 7 8 9 10 11, just giving counting there. So we have 11 groups there, but here we have so many. Here we have 11 bins, here we have too many bins, right? So what we can do, we can just go to this variable, go to new group, and here it will create bill length bins. Bins is group, like you are creating a group. Currently the bin size is 1.9. That means every bin here is representing a bill length of 1.9. I will say I want number of bins and it is suggesting 14. I say no, I give me 11. Okay. Now bin size will become 2.5. Let's see what happens. Now the bill length group is created. This particular icon, this small guy here, is a icon that represents group of a numerical variable. We will get rid of bill length. We will just drag this. Now you have a similar kind of chart that you would get in uh, your Python Seaborn, right? So this represents bill length distribution, and we can see most of the penguins the bill length is distributed in this range. Like most number of penguins in this group in bill length of 44.60, we have 61 penguins, right? So now this is okay, but how can we see effect of different species? Like this is data for all penguins, not for one particular penguin, right? Or three different penguins. So what we are going to do, we will again use legend here, species, which is hue or color, right? So you can see. So now this becomes interesting. Now it is showing you that your Adelie penguin, in case of Adelie, the range of bill length is from, let's say, 30 to 45 only. Okay, and in 30 to 45, most of them are in these two ranges, like 37 and 39. Okay, most number of penguins. But in case of chin strap and Gentoo, you can see you know longer bar for Gentoo. So you can see in case of Gentoo, we have a longer bar, obviously representing more number of penguins in 45 range, in 47 range, in 49 range, and so on. Okay, so obviously you can see from the graph also, because here you have selected build depth versus build length, so that's why you are seeing this. And as we have done it for build depth, okay, or so we have simply created groups for build depth, build length, body mass, and flipper length. So if I show you flipper length, it is easy. Just select number of bins, select 12. Okay. So here we have created. Suppose we want to see flipper length effect here, and we can remove this. Okay. Now whatever you want to see here, you can clip it like this, and it is showing count of ID by flipper length. So instead of count of ID, what we can do here, we can simply rename for this visual as, we can say count of penguins. Okay, and then it will be dynamic. So like count of penguins by flipper length and species. If you will change this and say body mass wise, we want to see the distribution. So we can see body mass of Gentoo is also higher than other penguins. So this is count of ID. Again, somehow it is not uh, letting us change. So let's say count of penguins. Let's hit enter. Yeah, count of penguins by body mass and species. And here also, so you can always change them. Like you can rename from here. So this particular type, this way you can see effect of different variables. Later in some other chapter, I will also teach you how to create filter options, so that you can create build length, build depth, this type of filter options, and make this a dynamic filtration. But that will be dealt in other chapter. There we can create this type of dynamic filter and select that. Now we have also created a simple filter here. So this filter here is the gender filter. So we have used, what we have done here, we have brought a simple slicer here, and in the slicer the field that we have used is this gender field, which is given as sex here. And after bringing the field, if you will go to the format your visual part, In slicer setting, we have selected the style as tile. Okay, and after doing that, it will start showing like this. If you will select drop down, it will start appearing like this. If you select vertical list, like this. So tile is good here. And here what we have done, in values, in background we have selected a color, and font color we have selected like this. So you can select a lighter font color also, a darker font color, whatever you prefer. Okay, so that it is properly visible. What we have done, we have disabled the slicer header. In general title, we have simply selected align center and make it bold. Okay, this way it will appear like this. And suppose you want to see for all male penguins, so you will be able to see that male penguins can be easily classified, like they are all different, you know so it can be easily classified using bill depth versus bill length, and also bill length versus flipper length. Here we have some clusters are mixing with each other, some scatter points are mixing with each other, but Gentoo in every case here also can be seen that Gentoo is the penguin which is heavier than other penguins and maybe bigger than other penguins also. And similarly, so male Gentoo penguin in this case we can see, and in case of female you can see their average values, etc. So this type of filters can be created, and right now we have deselected all the filters. Now similarly, let's say we want to see count of penguins by island. Let's try a matrix visual here. In matrix visual, in rows and columns we can bring two categorical values, and let's say in rows we will island, and in columns we bring species. Okay, now we have got this. What do you want to see in values? So in values we will simply want to see count of IDs. Okay, so count of IDs, and this way you will be able to see how many penguins are there. And what we can do, we can go to visual and just increase their size, and we also have space, so we can you know increase this length here, and this way you will be able to see that. You can also, and what this data is showing you is count of penguins in every island. Okay, so island wise penguins count. Okay, and we can use the same sort of setting here also. Just copy, format painter, apply here. Now just enable the title. So island wise penguins count here. We can see that in Bisco, for example, chin strap. Chin strap is only found in Dream Island. Okay, so chin strap is only found in Dream Island, and Gentoo is only found in Bisco. So this particular variable will be very much helpful in finding out the type of species of penguin on the basis of these values, right? That if it is in Bisco, we can very confidently say that it is Gentoo. If it is in Dream Island, if it is found in Dream Island, we can say it's Chinstrap. But in case of Adelie penguin, we have to see different values, right? Now what you can do, we can also see their average of something else. So we can take some other variable into account and see. So here, instead of count of ID, let's say what is their average body mass. Okay, instead of sum of body mass, their average body mass. And here you can see, let's visualize this. So in case of average body mass, we can see in case of Adelie, in Bisco 3709, Dream 3701. So Adelie and Chin Strap have their body mass very close to each other, but there is a difference of around 33 grams, which is very less. But Gentoo we can say is higher. And as I said, in these values, we can also put other values like average of flipper length, and let's get rid of this and say average of flipper length. So whatever variable you think will help you in finding out this information in a better way, you can just use that. I'm just showing you example of how to do that. In your matrix visual, you can go format visual. You have values, right? You have column headers, column header background color. We can select some different type of color, for example, like this. So we can select a darker color, and you have text color. We can select a light text color. You can also represent it like this. Okay, so here also we can do the same thing, like text color light, background color like this. Whatever you want to choose here, and this will also give you information. So in one particular graph, what you can do, this is our main dashboard, right? Let's say EDA. We are trying to see EDA dashboard. We are trying to see what variables, what values can help us in determining the species of a penguin. We can see from filter that yes, gender has a role to play. Like for different genders, we have different type of distribution of data. So it will help us in determining. We can say yes, island will also play an important role. We can also see that island wise different variables, like for example count of values or average, average of flipper length or average of bill length will also make a lot of sense. Whenever you are using a matrix visual, it is little bit different from a table visual. You can go to cell element, and in your cell element you can enable the data bars. So this data bar length will help you in determining which values are higher, right? For example, get to this value is higher, and you can go to data bar. Here you will see information like show bar only. If you will do that, so it will stop showing you the data. If you want to show data plus bar, let's say for positive bar, what color do you want to use? Okay, let's say we want to use this color. Just giving example. So this will give you that particular type of value. And in your data bars also, uh, we have negative bar, also we have axis also. So let's say we want axis color like this. Just let's see. So it will start displaying that. Our values are all darker color shades. So we will, that's why we'll choose a bar color that is something where we can see the visuals properly. So this is island wise penguin count, and this is island wise average flipper length. Island wise average flipper length. Okay. Similarly, what we can do, we can also copy it once again. Instead of count of ID, we can say island wise average body mass, right? So this is island wise average body mass, not sum but average. And just disable the default data, island wise average body mass. Like means if you are finding a penguin on a particular island, what can be their average body mass, and that is something you can visualize. Bisco body mass is 4719, Dream it is 3718, and Torgerson 3708. So in Dream Island and Torgerson Island in particular, We have pretty similar size penguins, but when you see them with penguin wise, then also this is also very much similar to flipper length. So, and that's why you can see flipper length versus body mass is also very related with each other. That they have a linear trend also. Like when you increase one of them, the other will also increase. We can again just resize this and create another copy of this to bring another visual in action. Now let's say this is again another type of chart that we can use is a ribbon chart. In ribbon chart on x-axis we put a species, or on y-axis we can put a species, but here let's say we are trying to see species wise data, and on y-axis we will bring average build depth. Okay, we will simply bring average build depth, not sum of it, but average build depth. And we can also bring gender as a legend. So this way you will be able to see, like for both type of penguins, whether male or female, you can see in case of male average build depth is 19.25. In case of female it is 17.59 in chin strap, 19.07 Adélie, 17.62 Adélie, right? 15 here and 14 here. So in case of Gentoo penguins, yes, they are higher. Like from other charts, we can see that they are heavier, sorry, but their build length is very small, right? Average build length is very small. That's why I said it may not be the best representation, but this is a simple penguins classification analysis dashboard which is used for machine learning, and the basis of this you can see which columns will help you in prediction of penguins, which columns will not help you. So if any column does not have any significance on the outcome, the value that we want to find here, so we can simply get rid of it. Otherwise this type of data will help you in analyzing you know any type of value. So in this type of cases, this is a supervised data set, supervised learning data set. You have some input and output samples. We have multiple inputs, multiple type of inputs, numerical as well as categorical, and we are seeing the effect of these variables on the output of which is a species of the penguin. And you can also adjust their height and weight and go there. This is not island wise average flipper length, so make sure every particular visual has a proper title. This is gender wise average build depth. Okay. And obviously there is a lot to explore here that you can explore anytime, but this is something that we can do easily. And we can also enable data bars here. So in cell elements we can enable data bars, select a different color just to give it a different type of feel. So here also we can enable data bars and select some color just to represent different type of values. So this is a simple dashboard that we can create out of the penguin dataset. If you would like to learn more, if you would like to learn more data analysis, please subscribe to our channel so that you can learn from the practical examples. We post these type of dashboards daily on our channel, so it will always help you. Thanks for watching.